The notion of light as an electromagnetic wave is also referred to as the wave model for light. Problem with that model is that towards the end of the 19th century, very late 1800s, okay, several experimental phenomena involving interaction of light with atoms and molecules could not be explained by the wave model. So, specifically the black body radiation, the photoelectric effect, and spectra of atoms and molecules could not be explained by thinking of light as a wave. And apparently the solution to all of these problems was to think of light not as a wave but as a stream of particles called photons. And so in other words, instead of thinking of light as delivering energy as a wave, think of it as delivering energy in bundles. Each bundle of energy is called, we now call it a photon. Okay? So this is known as the particulate model of light. So the energy of a photon is proportional to the frequency of the light. So there is a connection between the wave model and the particulate model. The energy of the photon is directly proportional to the frequency of the light if you were to think of it in terms of the wave model. That proportionality constant, given by symbol h, is called Planck's constant, after Max Planck, who was able to explain the black body radiation by and so that value of h, we now know the modern value for that constant is h is 6.626 times 10 to the negative 34 joules second. Basically what this says, the higher the frequency of the light, the higher the energy that each photon of that light carries. Okay, so higher frequency means more energetic photons. So if I were to ask you which has more energetic photons, radio wave or X-rays, what would it be? Well, you would say that X-rays would have higher frequency and therefore higher photon energy. Okay? Let's calculate the energy of a photon of red light with a wavelength of 632 nanometers. Then all you have to do is say energy of a photon is equal to h times nu. Since we're given the wavelength, we can calculate the wavelength from frequency. Frequency from the wavelength. Frequency is c over lambda, so we can rewrite this as h times c over lambda. H is 6.626 times 10 to the negative 34 joules second. Speed of light is 2.998 times 10 to the 8th meters per second, divided by wavelength, 632 nanometers, so 632 times 10 to the negative 9 meters. And so the energy of each photon in this case is equal to 6.626 times 10 to the negative 34 times 2.998 times 10 to the 8th divided by 632 times 10 to the negative 9 meters. That gives you 3.14 times 10 to the negative 19 joules. Okay? Seconds cancel out, meters cancel out, your unit is in joules. You can see this is a very small number, 3.14 times 10 to the negative 9. All right. Now, the frequency of radiation used in a microwave oven is 2.45 gigahertz. What if you have a 600-watt microwave oven, use it for 60 seconds, how many photons are generated? Well, to get the number of photons, right, then the number of photons times the energy of one photon, right, one photon would be equal to the energy of the n photons, right, the total energy. And so we have the frequency, so we can calculate the energy of one photon. We're looking for the number of photons, so we just need to know what the total energy is and what's the energy of one photon. 600 watts, 60 seconds. Power is energy per unit time, right? And so you multiply that by the time, power times time, gives you the energy. So that's your energy total. So you can get N here is E photon, E of one photon, over the total energy. I'm sorry, it's the other way around. It's divide both sides by E of one photon, right? E photon. So total number of photons is the energy, total energy divided by the energy of one photon. The total energy is 600.0 watt, which is a joule per second, multiplied by 60 seconds. Seconds cancel out. That gives you the total energy in joules. You divide that by the energy of one photon, which is h nu. So the energy of one photon is h nu. So what's our h? 6.626 times 10 to the negative 34 joules times seconds. That's the value of h. And frequency is 2.45 gigahertz. So 2.45 times 10 to the 9th per second. Hertz is per second. Okay. Giga means 10 to the 9th. So a gigahertz is 10 to the 9th per second. So the answer here will be 600 times 60 divided by 6.626 times 10 to the negative 34 divided by 2.45 times 10 to the 9th. And that gives you, in scientific notation, 2.22 times 10 to the 28 photons. Okay? So 2.22 times 10 to the 28 photons. This should not be joules. This should be number of photons. That's your answer. Okay?